Okay, so the next question that we have here is find the equation of the circle passing through 0, 0. So the circle passes through 0, 0, 0, and making intercepts A and B on the coordinate axis. It makes intercepts A and B on the coordinate axis. Coordinate axis. Okay, so this is basically a case that you can use in many different, I mean, this you could actually consider as some sort of a general case, and would be something useful. For example, if we said that we said that basically if the circle is generally x minus h whole squared plus y minus k whole squared is equal to r squared, if the circle is basically, if the center is at 0, 0 at the origin, then it becomes x squared plus y squared is equal to, for example, r squared. So this is one of the things that, for example, this is one of the forms of the equation of a circle that comes in handy in many different situations. Now suppose that you have a circle. Suppose that you have a circle that passes through 0, 0. It passes through 0, 0, and makes basically intercepts A and B on the coordinate axis, meaning that suppose that, for example, your circle is that the center is over here, and then your circle basically makes these intercepts on the coordinate axis, for example, over here and over here. Or if the center is, for example, over here, then the coordinates, then it passes through the same point here, some point over here. Or basically, if your center is, for example, somewhere over here, it goes through this point, some point over here, some point over here, and so on and so forth. Now, in order to get a general equation for this form of the circle, or a form of equation for this kind of situation, basically you know that your circle goes through this point, and also this point, and also this point. That means that you know that your circle goes through, let's call this, for example, this point over here, let's call it, for example, a comma 0, and this point, let's call it, for example, 0, b, and this point over here is 0, 0. So if that's the case, now in this situation, your b can be a negative number, in which case you would get a circle down here. It could be a positive number, in which case you would get a circle up here. A could be positive or negative, and then your circle can be moved to the other, to all the 4 quadrants over here. So since you know that your circle goes through the points 0, b, and 0 and a, 0 and 0, 0, so basically you know that the equation of a circle is x minus h whole squared plus y minus k whole squared is equal to r squared. Now if your circle goes through the point 0, 0, you will get basically h squared plus y plus k squared is equal to r squared. You can call this equation number 1. If your circle goes through a, 0, you will get basically x minus a whole squared plus I'm sorry, this is a mistake. If your circle passes through a, 0, then your x is equal to a. So that's a minus h whole squared plus, now your y is equal to 0, so there you have k squared is equal to r squared. Call this equation number 2. And if your circle goes through 0, b, then you have basically your x is 0, so you have h squared plus your y is basically b, so b minus k whole squared is equal to r squared. Call this equation number 3. So what that means is that you need to somehow, using these 3 equations, okay, so now from these 3 equations you somehow need to find out what is h and what is k, and this is of course h over here. What is h and what is k and what is basically r. Okay, so I suppose, well, you could say that of course I don't really know, you could do this in many different ways, but I can imagine that I can write, for example, but since basically only a and b are given here in the problem, that means that you need to find everything in terms of a and b, meaning that your r has to be in terms of a and b, your h has to be in terms of a and b, and also your k has to be in terms of a and b. So what that means is that, for example, if you compare these 2 equations, you see that you have r squared on the right hand side, you have k squared, and then you have basically h squared and these 2 terms over here. That means that from 1 and 2 I can write h squared is equal to a minus h whole squared, which means that h squared is equal to a squared plus h squared minus 2 times ah, and h you can cancel out, and what that means is that basically a times a minus 2h is equal to 0. Either your a is equal to 0, which is not possible because you want to have some a over here. You don't want your a to be 0. Or you can say that basically a minus 2h is equal to 0, which means that a is equal to 2h. A is equal to 2h. Or you can say that basically, of course this is not going to help me, So you can say that if basically a minus 2 is equal to 0, you can say that a is equal to 2h, or basically h is equal to basically h is equal to basically 1/2 a. 1/2 a. So your h is equal to 1/2 a. So divide by 2, you get h, and divide by 2, you get 1/2 a. So now if your h is equal to 1/2 a, your h is equal to 1/2 a, now you see, for example, in these two equations, so over here you have basically b and a and h and k. A, B, H, and K. Over here you have, and over here you can find the value of K basically. Meaning that if you compare these two equations 1 and 3, basically 1 and 3, what you will get is that basically you have r squared over here, you have h squared over here, so you can write k squared is equal to b minus k whole squared. B minus k whole squared, which means that k squared is equal to b squared plus k squared minus 2bk and k squared you can cancel out, so then b squared minus 2bk is equal to 0, and so that means that b times b minus 2k is equal to 0. That means that either b is equal to 0, which is not acceptable, or b minus 2k is equal to 0, which means that b is equal to 2k, which means that k is equal to 1/2 b. So the value of k you can find this way as well. And so the value of r, there is only one thing that remains here. The value of r, you can write it as basically this way, using this equation. So you have h squared plus k squared is equal to r squared. Number 1, h squared plus k squared is equal to r squared. So h squared is equal to 1/2 a whole squared. K squared is equal to 1/2 b whole squared is equal to r squared. And so that is 1/4 a squared plus 1/4 b squared, which means that, which is the same thing as is equal to r squared. That means that r squared is equal to 1/4 times a squared plus b squared. So that is the value of r squared that you need in your equation. Now h is equal to 1/2 a. H is equal to 1/2 a. So now what that means is that if you write the equation of a circle as x minus h whole squared plus y minus k whole squared is equal to r squared, over here you can write basically h is equal to 1/2 a minus 1/2 a whole squared plus y minus k is equal to 1/2 b whole squared is equal to r squared, which is equal to 1/4 a squared plus b squared. A squared plus b squared. This is the equation of the line. This is the equation of the circle passing through the origin, and creating x and y intercepts, on the basically A and B on the coordinate axis. So that is basically that. I suppose the answer is right. So number 13. And of course they have simplified this, which is actually not a bad idea. Let's simplify this. Let's see what we get. So I have basically x minus 1/2 a, so I write this as x squared plus 1/4 a squared plus or minus, let me see, negative 2 times x times 1/2 a, and 2 and 2, so that is xa. Negative 2 times x times 1/2 a is 2. These two will cancel out and you will have negative xa plus basically here you have y squared, here you have 1/4 b squared, 1/4 b squared, and over here I have negative 2 times y times 1/2 b, so these two will cancel out, so that's negative by, and over here I have 1/4 a squared plus 1/4 b squared, and so if you 1/4 a squared and 1/4 b squared, you can cancel out here. So that means that you can write x squared plus y squared minus ax minus by is equal to 0, which is the equation of the circle. So this is actually this thing over here. So the equation of the circle passing through the origin and creating x and y intercepts a and b on the coordinate axis is basically this thing: x squared minus y squared minus ax minus by is equal to 0. You can probably write this down somewhere as well. I'm going to write it down in my notebook. It will come in handy someday. So let me pause the video. Okay, so the next question that we have, we want to find the equation of a circle with center 2, 2, center 2, 2, and passes through the point, through the point 4, 5. So this is not, it's not very difficult to solve this problem, Because if you know where your center is, for example, suppose that this is your circle and this is your center. Suppose that this is your circle and this is your center. So if suppose that your center is 2, 2, and well, let's say that, for example, this is coordinate axis and 2, 2 is over here. So this is your center, and 2, 2 and 4, 5, 3, 4 and 5 is basically over here, and that the circle passes through this point. 4, 5, meaning that you have basically something like this, probably. I mean, of course, it's not the best circle that I've ever drawn, but you get the idea. Now, if that's the case, of course, it's supposed to be somehow. Let me write this. It comes over here and goes over here and it goes over here, somewhere goes over here, goes over here and goes over here. So our circle is actually supposed to go through these points. I apologize for the messy circle, but I'll take care of it. Okay, so this is your circle. So 2, 2 is your center and goes through this point, which is 4, 5. Now, of course, your center, since you know where your center is, this is your h, k, meaning that you know that h, k over here is basically 2, 2. And the only thing that you need over here is your r squared, and then you would be able to find the equation of the circle using x minus h whole squared plus y minus k whole squared. X minus h, y minus k is equal to r squared. So we have our h and k, and so the only thing that we need is r. And your r is basically you can calculate using the distance formula, meaning that you can find the distance between these 2 points. You know that AB is equal to basically x2 minus x1 whole squared plus y2 minus y1 whole squared. And that is the distance formula. So now these 2 points, you have 2, 2 and you have 4, 5. So then the distance between these 2 points, if I call it AB, for example, just arbitrarily, you'll get 4 minus 2 whole squared plus 5 minus 2 whole squared, which is equal to basically the square root of 2 squared plus 3 squared, which is equal to the square root of 4 plus 9, which is equal to the square root of 13. So this distance is the square root of 13. That means that your r is equal to the square root of 13. So now you can write basically the equation of the circle, meaning that since you know that based on this equation, if I call it number 1, based on this equation you have x minus h, which is x minus 2 whole squared plus y minus k, so y minus 2 whole squared is equal to r squared, which is basically square root of 13 squared is equal to 13. So you can write this as x squared plus 4 minus 4 times x plus y squared plus 4 minus 4 times y is equal to 13. And then you have x squared plus y squared, negative 4x, negative 4y, negative 4x, negative 4y. And then you have a 4 and 4 over here, which is equal to 8. 8 minus 13 is equal to negative 5 is equal to 0. That is the equation of your circle. Let me check the answer over here. 14. X squared plus y squared minus 4x minus 4y is equal to 5. That is your circle. And the last question in these questions is number 15. Does the point lie inside, outside, or on the circle x squared plus y squared is equal to 25? Okay, so basically the question is, it's a good question. It says, does the point negative 2.5 comma 3.5, does it lie inside? Does it lie inside, outside, outside, or on the circle? On the circle, x squared plus y squared is equal to 25. Okay, so what this means is that, well, when you see the equation of the circle, you see that it's x squared plus y squared is equal to 25. That means that you have x minus 0 whole squared, for example, plus y minus 0 whole squared is equal to 25. That means that your center is at 0, 0, which is the origin. So your center is the origin. Center the origin. And since the center is origin, and then this is now basically r squared, because you have x minus h whole squared plus y minus k whole squared is equal to r squared. So that means that your r squared is equal to 25. That means that r is equal to 5. So that means that the distance between, for example, let's say this is 1, 2, 3, 4, 5 units, 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 and that is basically your circle. That is your circle. And in every direction the distance is just simply 5 units. 5 units. 5 units, and so on and so forth, and that's equal to the radius. Now this point over here is negative 2.5, which is basically this point over here. Negative 2.5 and 3.5 is somewhere over here, so of course the point is inside the circle. Now if you want to verify this algebraically, you do need to basically what you need to do is that what I would do is that basically I would find that the center of the circle, which is in this case 0, 0, and the distance of this point from 0, 0, and then if that distance is greater than the radius of the circle, then that means that then basically the point is outside, otherwise it's inside. Or you can say that that's what I would do. 15. Yeah, and the answer that we have here is the same thing. It says that inside the circle, since the distance of the point to the center of the circle is less than the radius of the circle. That's basically what that's exactly what I said. So in order to decide whether this point is inside or outside the circle, all you need to do is find the center of the circle and then calculate the distance using the distance formula. Calculate the distance of this point from the center of the circle, which is in this case the origin. And now if this distance is greater than the radius of the circle, then of course the point is outside. If it's less than the radius of the circle, it's inside. If it's equal to the radius of the circle, then it's on the circle. So that's basically how you could solve this problem. Okay, so in the next video, what we have is a little bit of I mean, almost everything that we did about the circle, now we need to do about the parabola. So we need to derive its equations, and there are a couple of things related to parabolas that we need to know, and then there are a couple of examples or exercises. So I'll have to go through this part myself a little bit, get myself familiar with the equations and everything, and then I will basically explain this a little bit briefly to you as well, and then we will do the exercises. So I'll see you in the next video.